3. Find the equation of the line parallel to the line y equal to 2x plus 4 and passing through the point 6, 2. Okay, so we know that the gradient, the intercept form of straight line is y equal to mx plus c. So for this one, the gradient is 2. Okay, so this one I will say is the gradient 1. So the gradient 2 is equal to gradient 1, that is equal to 2 because they are parallel. Okay, so the y equal to 2x plus 4 should be something like this, and then we have the other line, okay, that is parallel to this y equal to 2x plus 4, okay, and then pass through the 6, 2. So y equal to 2x plus 4, okay, and then the other line, okay, so this one is the gradient 1 is 2. So the second one, the gradient is 2, and it passed through the point 6, 2. Okay, so the gradient of second gradient is 2 and it's passed through the point 6, 2. So we have the y minus 2 equal to 2x minus 6, 2x minus 12 plus 2. So y equal to 2x minus 10. Okay, so we have this one, expand, move. So this is the solution. So we look at B. So it parallel to this. Okay, so it is parallel to this one, and then pass through the 2 minus 5. Okay, so this is the gradient 1, x plus 2y equal to 5. So we have to write the equation as y equal to mx plus c. Okay, so we have this one move to the other side. So we have the 2y equal to negative x plus 5. So y equal to negative half x plus 5 over 2. Okay, because I divide by 2 here so that it is a y. So the gradient 1 is negative half. So negative half. So the gradient 2 is equal to negative half. So the gradient 2 equal to gradient 1 equal to negative half. And it passed through the point 2, negative 5. So y minus negative 5 equal to negative half x minus 2. So we have the negative half x plus 1 minus 5. So y equal to negative half x minus 4. So C, we need to find the equation that perpendicular to this line and then passing through this one. So if perpendicular, okay, so for two lines that is perpendicular, okay, we have the gradient 1 and gradient 2. Perpendicular, we have a 90-degree here. So the relationship between the perpendicular, that is the gradient 1 multiplied with the gradient 2 equal to negative 1. So for this one, we have the 2x plus 3y equal to 12, 3y equal to negative 2x plus 12. So y equal to negative 2 over 3x plus 4. Okay, because we want to write as a y equal to mx plus c. Okay, so that's why I divide by 3 here. So I move this to this side. So y, okay, as a subject. Okay, so we have the gradient 1 is negative 2 over 3. So the gradient 2 will be negative 1 over the gradient 1. Okay, because the gradient 1 multiply gradient 2 equal to negative 1. They are perpendicular to each other. Okay, so when they are perpendicular to each other, then the gradient 1 multiplied gradient 2 is negative 1. Okay, so so I want to find the gradient 2, then will be negative of 1 over gradient 1. So it will become 3 over 2. So actually it's very easy. Negative become positive. And then we find the reciprocal. So 2 over 3 become 3 over 2. So they are perpendicular to this one and then pass through the 7, 2, 7, 3. Yes. So we have the 3 over 2 and then 7, 3. Then we use the formula y minus y1 equal to mx minus x1. So we have the y minus 3 equal to 3 over 2 x minus 7. So we have the 3 over 2x minus 21 over 2 plus 3. So y equal to 3 over 2x and minus 15 over 2. Okay, so we have the 3 minus 21 over 2. Okay, that is negative 15 over 2. So what I did here is actually I changed so that their denominator are the same, both two. Okay, so negative 21 plus 6 is negative 15. Okay, so perpendicular to the line this and pass through this. So I move the y here and here. So we have the 4x minus 6 equal to 1. So y equal to 4x minus 6. So the gradient 1 is 4. So the gradient 1 multiplied with the gradient 2 equal to negative 1. So the gradient 2 equal to negative 1 over gradient 1. So negative 1 over 4. Okay, so the gradient 2 is negative 1 over 4 and it's passed through the point 4, negative 1. So we have the y minus negative 1 equal to negative 1 over 4 x minus 4. So we have the negative 1 over 4x plus 1 and then minus 1. So the y equal to negative 1 over 4x.